Okay. Actually, Jake, can you wait till I go over this and you can go?
Yes.
All right. So, number 10. CH3COCH3. All right. So here's how I would approach this. I have this carbon with 3 hydrogens. I have this carbon with 3 hydrogens. How can I get a C and an O between them so that this C has 4 bonds and this O has 2? Because if I do this, that doesn't fly. That doesn't work. Why? This doesn't have 4 bonds. Well,
you put the C and the double bonded O on top.
yep. So this C goes here. The O is double bonded to that C. Now this C is bonded to that C. It's a ketone.
Oh, that's weird.
Yeah, that's why I did it this way, because I want you to see the weird version. I hope the Regents does this. It probably will, but you might see something like number 10. You might. I have to, I have to make sure we see everything. All right, Jake, you go. So, I wouldn't stress too much. If you're all worried about that and that's like super confusing, I wouldn't worry too much. If you can look at this and tell me it's a ketone, you're in a good place. All right, number 11. What is it? Alcohol. It has an OH. Only an OH. No C double bond O. Just an OH. Number 12. Organic acid. COOH. Like that one. We'll name it in a minute. You can, but 13. Ester looks just like this. C double bond O with an O. 14. Ketone, just like this one. C double bond O with nothing else. That's a ketone. 15. Aldehyde, because it looks very similar, but it has the H, right? It has that H at the end, so that's the aldehyde. That's what separates it. The aldehyde is always kind of at the end of the chain. Technically the beginning, but it's always going to be at the end because it has the H. Ketones are always somewhere in the middle. And 16. Right, ethers. Ethers, sorry, get the hang of it. Ethers, oxygen in the middle. So again, you're matching it up with what you see on table R. All right. So now let me draw number 12, and then Tyler's going to take a stab at this here. Oh, how'd you guys do in lab?
Good.
Most
I
of
finished it.
you did? Like the whole thing?
Yeah.
Okay, good, good. Because we'll give some time Friday to finish it up, but I want to do something else with you guys. And then next Tuesday we have lab again. Yeah, and then the 9th, Mrs. Carr's coming in. She makes soap. Is anyone familiar with this? I know she did. So making soap is an organic reaction you guys need to know. It's called saponification. So she's going to come in, make soap, explain it a little bit, and I'll explain some things. But you're going to see the process. So it's kind of cool. So she's coming in next Thursday. So Friday and Tuesday, there's some things I want to do with the labs that I need time for. So
Was the one back there supposed to be missing a hydrogen?
no, someone probably took it off.
I put one on.
Break their fingers. All right. I'm being recorded. I'm just kidding. I don't want to fight here. I'm not going to actually break anybody's fingers. All right.
As far as you know.
Here we go.
Break someone's chicken fingers.
So this is number 12. That's number 12. Right? Yeah. Okay. Go to table R. Look all the way to the right of organic acid. What's the name in the box? Propanoic acid is how you say it. Propanoic acid. Organic acids always end with the oic acid part. It's really nice to have this example, this column here, this chart, so it can help you name these things or draw. So anyways, why is it pro? Because there's 3. So go ahead.
Butanoic acid.
Very good, Tyler. Butanoic acid is the name because but means 4. 1, 2, 3, 4. Kind of like butane, but it's butanoic acid because that's C double bond OH. Good. All right, put that away. Take out your notes. We're going to take the last 10 minutes to just practice naming and drawing these things. The best way to learn this is practice. I could give you a whole bunch of notes and just tell you things, but I think practice is better. All right, so in our notes, I don't know if we actually wrote this yesterday, but functional groups, just so you have kind of like a heading on what are we doing here, what's in the notes. I know we talked a little bit about boiling points yesterday, and I just wanted to recap. The bigger the molecule, the higher the boiling point. That was what the lab was supposed to help you see with the graph, the trend. And again, the surface area, not to confuse you guys, but in general, the longer the chain, the more surface area, so it's going to be harder to boil, so higher boiling point. So that's kind of where we ended yesterday. Today we're going to practice naming and drawing these things. But before we do that, just a quick kind of definition or explanation. What are functional groups? They are groups of atoms attached to hydrocarbons, and mostly alkanes, hydrocarbons, which change all the chemical properties.
So they're
Chemical and physical, sorry.
So they're technically not hydrocarbons.
Right, because now they have O's and N's, right, so they don't have just C's and H's. Change all the chemical, sorry, chemical and physical properties. So like I said earlier, ethane boils at negative 88 or something like that. You stick an OH on and make an alcohol, it boils at 78. So just that one little change, making it an alcohol, completely changes the properties. So that's what they do. That's why they are a thing. That's why there's a chart, because it's a whole different class of compounds. They react different. They do different things. So if you take crude oil, separate into different hydrocarbons, and start sticking OHs or C double bond O to, it changes everything. And that's what organic chemists do, and a lot of cosmetics and cleaning supplies and solvents, a lot of that stuff from warehouses and companies that do that stuff, they create those things. This is what's going on. They're doing chemical reactions involving these functional groups. All right, so I'm going to draw a structure here. I want you to draw it and try and name it. I'm going to give you a name. Write the name down. Try and draw it. We'll see if we can get through 4 examples. 2 and 2. Here we go. So here's your first one. So write that down and then try and name it. And I realize if you make a mistake, it might make your notes messy, but I really want you to try. If you use pencil, it's not a big deal. So try and name that, and then I'm going to give you another one here. There's a name. I want you to try and draw it. Draw the structure, but make sure you get both in your notes, right? So put these in the notes and then have the structure under it and the name under it. The one on the right, that name is pronounced pentanal. Pentanal, and the reason for that is it's an aldehyde. My chemistry teacher in high school had this little phrase for aldehydes. I didn't have table up. I had to memorize all this stuff. So he had this weird little phrase. He would say, "Yo cho, al's my pal." Yo cho, al's my pal. The yo is just like whatever. But the cho, al's my pal, is because aldehydes have CHO as the functional group, so that's the cho. And the reason he would say al is my pal, it's kind of silly, because he wanted us to say it correctly. So that's pentanal, because aldehydes, they're your pal, it ends in al. So he really stressed that, because it's important to identify the AL ending means aldehyde. That's really important. So that's why I'm going over it right now. Oh, I thought you came back. No, that was this guy. There you go. What's that?
Oh.
So AL. Oh. Is AL. So we're down here at the alpha. So that's okay. I use you as an example. Okay. All right. Yeah, I embarrassed Tara this morning. it's common that students think the one on the right is an alcohol. Because when you read it, you read pentanol. Like that's kind of how we would read it. Again, my whole little spiel about telling what my teacher said, pentanal, it's really important. When you see that AL, you read al. Hopefully that clicks. Oh, al, what's that? Aldehyde. So now you know the one on the right, it doesn't have an OH, it has the aldehyde group. And that's where the name comes from. What's pent stand for? 5 carbons, right. So I think, I think most of us are good with that, all of us.
Does it matter where you put the OH?
Say that again, Veronica?
Does it matter where you put the OH?
This one?
No, for pentanol.
There is no OH.
It's just an alcohol.
Yeah.
I mean, and CO.
Oh, I'll get to that. So we'll get to that in a second. This is an alcohol. So what does that mean? So if you go to your chart and you say, okay, I know it's an alcohol because I see the OH, look at the name, they give us propanol. Prop because there's 3 carbons, and the OL is just how it ends. That's how alcohols end, with an OL. So who thinks they could give me the name of this? Ethanol. Right. It's like ethane, except because it's an alcohol, it ends in OL. So instead of ethane, it's ethanol. Yes.
Do you need to write 1 ethanol?
You could.
Ethanol?
You could write 1 because it's
Okay.
on the first carbon. It's the same. So you can have it or not, it doesn't matter.
Okay.
Because if we put it over here, it's still 1. So in this case, it doesn't matter, but down the road it will. All right, so pentanol. 1, 2, 3, 4, 5. All right, so Jake Flower, aldehyde. What must be present? What functional group? For the aldehyde. Have you been sitting here the whole time without table R?
Yeah.
Why would you do that?
Because I was like,
Because you're not with me. You need to be with me, Jake. This is the whole ball game. Is this chart? Alex, what functional group do we need here? What elements? How am I going to draw it?
Well, it's a double bond O.
Yep.
and an H.
Good. Double bond and O with an H. Doesn't matter. Back to Nautica where it goes. Like, can I put the double bond O and H right here?
I believe that's the end.
It does have to be on the end. Very good. So now.
Doesn't
you-
matter which ends, that's what I'm
No. So you could do this, or you can do it over here.
Okay.
Doesn't matter. Good question. And in fact, you could put the double bond O going down, or to the right, or to the left, or down. Doesn't matter. Go ahead.
what is, like, is there ever, like, a 3 pentanol?
So no, aldehydes are always going to be at the end.
Okay.
Yep. Okay. Your homework's going to kind of practice that a little bit. I'm going to see how you guys do. We'll go over it tomorrow. All right, 2 more. Maybe we'll do these together to make sure. Well, we got 4 minutes. So. All right, I'm going to draw one again, and I'll give you a name. Here we go. What did I give this morning? I remember this one. This one, dimethyl ether. Dimethyl ether is that one. What was the one I drew? It was a good one. Well, go ahead and work on that. I'll just give you a different one. So I'll give you like a minute. That's all, because I want to make sure I go over it. Try and name the one on the left, try and draw the one on the right. Using table R is the whole key here. Look up the functional group, look at the example, because the example not only helps you name it, it helps you draw it. The good thing is the how we learn to name the hydrocarbons, the IUPAC method, applies to this. It's the same concept. It's just these are a little more complicated. Alright, for the sake of time, I'm just going to go over it. I know you may not be done. This one here, who can tell me what functional group? Ketone. So I know it must end in "-one". Looks like one, but it's "-one". How many carbons? 4. What's the prefix? Bute. So it's butanone. Butanone, and where is the double bond? 2-butanone. That's the name of that. 2-butanone. Again, how do you know this? How do you know it ends in "one"? Because table R. It shows you how to write the name. You just have to use the example to help. Now over here, ether is that. Now the example they gave you was methyl, ethyl, ether. So, this one is dimethyl. What does that mean? There's a methyl on each side. Very good. One methyl here, one methyl here. That's dimethyl ether. Those are confusing. Those are confusing. Who was that? Yep, it is. Alright, so that's it. Bell's going to ring really soon. Do the best you can on the homework, and we'll go over that. That was good. We got some things done there.